Assalamu alaikum everyone. I'm Mansoora Nazneen and today I'm going to presenting the paper titled Time Complexity Reduction of Coding Unit Splitting in HEVC Intra coding using a Zerocross Edge Detection method. Here is the authors of our research work. We are all from our Department of Computer Science and Engineering, Rajshahi University of Engineering and Technology. Here is the outline of our presentation. So video is a 3D signal which is mainly collection of frames or images over time, and higher the frame rate, the movement is smoother in the video sequences. And video compression is mainly a technique of encoding a video file so that it takes lesser space to be transmitted. Where here we can see an example of temporal and spatial redundancies between the video frames, and mainly we compress video between, based on these redundancies. Video compression is mainly needed for optimizing storage capacity, increasing transmission speed over transmission line, and multiple device compatibility. And video coding is widely used in video call services, live streaming, or storage media. There are many video compression technologies available nowadays. AVC, commonly known as H.264, uses a block-based orientation motion compensated coding. H.265 or HEVC increase the data compression ratio, maintaining the quality compared to AVC. And VVC is a new generation video compression technique, and VVC saves up to 50% bitrate compared to HEVC, but increase the time complexity on both encoding and decoding side. Here is some recent work on a video compression. An approach named HDR has been introduced for decision making in HEVC inter-depth range. And in this research work, 27.54% encoding time is reduced and 0.99% bitrate is increased. Another reference paper used decision tree as classifier, and in this paper, 42.1% encoding time is reduced and 0.7% bitrate is increased. Here is some other works who uses various algorithm and classifier. So all modern video codec use flexible block partitioning during rate distortion optimization process and Lagrange rate distortion cost function. As a result, it minimizes the bits but increase the time complexity. So purpose of our study is reducing time complexity, finding a faster heuristic approach which will decide whether a block has motion discontinuity or not and skip the audio process. And reason behind choosing heuristic approach is that large datasets are used by machine learning models to learn from video properties, which may increase the time complexity. But in heuristic approach, deciding CPU partition are faster than machine learning models because they doesn't require time for training, testing, or validation. So major challenge of our study was reducing time complexity with negligible increasing of bitrate. So it's the workflow diagram. At first we took current frame, then edge detection, then we detect object, skip the rate distortion optimization process, HEVC encoding or decoding. Here's the test video sequences we used for this research work. We used 12 commonly used sequences provided by JCTVC. So now moved on to zero crossing edge detection. Zero crossing edge detection in this edge detection, at first we calculate first derivative to detect local extremes, and then we calculate second derivative to indicate zero crossing. So it's the steps of zero crossing edge detection. At first, second derivative calculation to measure how the intensity changes over spaces, both in horizontal and vertical vertical. And then zero crossing detection to check the signs of second derivative values at neighboring pixels. And after that, thresholding for edge detection. Thresholding is employed to separate the significant edges from noise. Now, advantages of zero crossing edge detection method over other edge detection method is more robust to noise, produce thinner and more localized edges, and enhance the edges, making them more pronounced and easier to detect, and maintains the connectivity of edges better. Here is an example of zero crossing image. This example is from the sequence basketball pass. Here's the details of our proposed model. In our task here is to find whether block has object or not. So at first we took a video frame from the video frames, then find the edges of the frame using zero cross method. Then we divide the whole frame in 64 by 64 blocks. Take each block of the frame and find summation energy of the values. If the summation energy is greater than 0, then the block has object, and it will partition further. And if the block doesn't have if the block summation energy is less or equal 0, then the block doesn't have object and it will not be partitioned further. Here is the equation to calculate the energy. So reason for choosing a Zerocross image is that it's simple and low computational complexity and efficiently identifies edges of the moving objects. Here's the visualization of the partition process of a coding theory unit in HEVC Intra coding for 64 by 64 blocks to 8 by 8 blocks. Here we can see a block of 64 by 64 and its further partition and structure of our coding to unit partitioning in level 0, level 1 and level 2. So a 64 by 64 block may have 4 32 by 32 blocks, 16 by 16 blocks, or and 64 8 by 8 blocks. So 8 by 8 blocks will not divide further. So we need only a array of 21 size to save all the partition information. Here is the example of a coding tree unit partitioning. This frame is from basketball pass sequence, frame number 1. So in our performance measurement criteria, 101 frames of each sequence are used two-step analysis in two-step analysis process. At first, frames were encoded using existing version of HM 16.20. Then again, we encoded the same frames using the modified version of HM 16.20 encoder. For bitrate calculation, we use John-Taker delta bitrate piecewise cubic interpolation method, and HM 16.20 is used as we mentioned before. For encoding time, we used this equation, and we commonly used for quantization parameter 22, 27, 32 and 37. Here's the performance analysis of the sequence BQ square. This sequence resolution is 240p, and here we can see the frame number 10 of this sequence. Here's the edge detection of the frame 10 of the same sequence. At picture A, we can see the edge detection using Zerocross, and in picture B, we can see the coding to unit partitioning. Here is the visualization of coding to unit partitioning. Left-sided frame is partitioned by HM encoder, and right-sided frame is partitioned using Zerocross method. Here is the visualization of decoded frame. Left side frame is decoded by HM encoder, and to decode this frame, it need 317.34 seconds, and right-sided frame is decoded using Zerocross method. It need 174.22 seconds. We can see that there is not so much differences in visualizing the both frames. Here's the encoded summary comparison between HM encoder and modified HM encoder for the sequence BQ square. Here's the John-Taker curve. We can see that both HEVC curve and proposed methods curve are same. Here's the final performance analysis. Average PSNR is minus 0.04, average bitrate is 0.47, and average time saving is 45.21%. Here is some other example, C2 partition of the proposed method versus HM encoder, and visualization of coding to unit partition of the sequence basketball pass. Here is the C2 partition visualization of the sequence ray sources. Here is the visualization of decoded frame of the sequence blowing bubbles, and here is the John-Taker curve of the sequence traffic, and we can see that both curves are almost same. Here is another John-Taker curve from the sequence cactus, which is 1080p resolution. Another John-Taker curve of basketball drill sequence. So is the final summary of our all encoding results. From the summary, we can say that average PSNR is minus 0.17, average delta bitrate is 3.35%, and encoding time is 44.54%. Here we compare the proposed method with one of the reference paper, HIDR-CNN. In the reference paper, we can see their time complexity reduction is only 21.61%, where our reduction is 44.15%. So our proposed model, Zerocross model successfully decided for the blocks whether it had multiple motion or not and plays a vital role. 44.54% time complexity is saved on average, while in cactus sequence has the biggest improvement in time complexity, 49.49%. and 3.35% bitrate is increased, and for the big square sequence, bitrate increased is just 0.47%. So in our future work, we want to experiment using ultra high definition videos, and our target is to work on interframe redundancy and implementing our model in PVC. Thank you everyone.